By 1942 and 1943, the war was not going well for Nazi Germany. The tide had turned on multiple fronts. The Wehrmacht was bleeding in the Soviet Union. Allied bombing campaigns were intensifying over German cities, and the industrial might of the United States was beginning to make itself felt. It was in this increasingly desperate situation that the Nazi leadership became obsessed with what they called Wunderwaffe, or wonder weapons, revolutionary technologies that could somehow snatch victory from the jaws of defeat. We're talking about projects like the V-2 rocket, the first ballistic missile, jet-powered aircraft like the Me-262, and even more exotic concepts like sonic weapons and various types of ray guns. The Nazi regime poured enormous resources into these projects, often at the expense of more practical military needs. Hitler himself was fascinated by superweapons and was easily swayed by grandiose presentations of theoretical capabilities. This created an environment where scientists and engineers, competing for funding and favor, would propose increasingly ambitious and sometimes fantastical schemes. Into this mix stepped Hermann Oberth, a name that should be familiar to anyone interested in the history of rocketry and space exploration. Oberth was one of the founding fathers of astronautics, a brilliant physicist and engineer whose 1923 book, The Rocket into Planetary Space, helped lay the theoretical groundwork for spaceflight. He had mentored Wernher von Braun, who would later develop the V-2 rocket and eventually lead America's Saturn V program. But Oberth wasn't just a dreamer. He was a meticulous scientist who understood orbital mechanics, thermodynamics, and the practical engineering challenges of space technology. And it was Oberth, working at the German Army Artillery Proving Grounds in Hillersleben, who became associated with the development of the sun gun concept. Now, here's where things get really interesting. The concept of using focused sunlight as a weapon wasn't actually new. In fact, it dated back over 2,000 years to ancient Greece. According to historical accounts, though these are debated by scholars, the Greek mathematician and inventor Archimedes defended the city of Syracuse against Roman invasion around 212 BCE using an ingenious weapon, a massive array of mirrors or polished shields that focused sunlight onto approaching Roman ships, setting them ablaze. The story goes that Archimedes positioned soldiers or citizens on the shore, each holding a large bronze or copper shield polished to a mirror finish. By carefully coordinating the angles of these shields, they could concentrate the sun's rays onto a single point on a distant ship. The intense heat generated at this focal point would allegedly ignite the wooden vessels, causing them to burn. Now, modern experiments have shown mixed results when trying to replicate Archimedes' feat. Some teams have successfully ignited wood using this method under ideal conditions, while others have found it impractical for actual warfare. The story might be partly legendary, embellished over centuries of retelling. But the underlying physics is sound. You absolutely can concentrate solar energy to dangerous levels using mirrors or lenses. The Nazi engineers knew this ancient tale, and they saw in it the seed of something far more powerful. If Archimedes could potentially burn ships with Earth-based mirrors, what could be accomplished with a massive mirror positioned in space, with no atmospheric interference, capable of focusing the sun's full intensity onto any point on Earth? So what exactly was the sun gun? Let's get into the technical details because this is where the proposal moves from pure fantasy into the realm of, well, extremely difficult but theoretically possible engineering. The core concept was deceptively simple. Build a massive orbital mirror, position it in space about 5,100 miles above the Earth's equator, and use it to focus concentrated sunlight onto targets below. But the execution. That was anything but simple. The mirror itself, according to the surviving documents, would have been enormous. Estimates suggest a diameter of somewhere between 3 and 6 miles across. To put that in perspective, that's roughly the size of a small city. The structure wouldn't be a single solid mirror but rather a framework holding thousands of smaller mirror panels, all precisely aligned to focus sunlight at a specific point. The proposed design included several key components. First, there was the main reflective surface, made up of segments of sodium metal. Sodium was chosen because it's highly reflective and relatively lightweight. Critical factors when you're trying to launch something into space. The mirror segments would be mounted on a lightweight frame, possibly made of aluminum or magnesium alloys. Second, the station would need a power source and propulsion system to maintain its orbit and adjust its position. The engineers proposed using solar panels, ironically, using the sun's energy to power a weapon that used the sun's energy to generate electricity for electrical thrusters that could make fine adjustments to the station's orientation. Third, and perhaps most challenging, the weapon would require an incredibly sophisticated targeting and focusing system. Remember, this mirror would be orbiting at roughly 5,100 miles altitude, moving at tremendous speed, while trying to focus a concentrated beam of sunlight onto a specific target on a rotating planet. The calculations required for this would have been extraordinarily complex, even by today's standards. The documents also describe a pressurized section that would house a crew of German scientists and soldiers. These crew members would operate the weapon, perform maintenance, and presumably, make the final decisions about targets. The proposal suggested the station could be supplied by rockets, an idea that was at least theoretically feasible given that Germany was already developing the V2 rocket by this time. According to the plans, the focused sunlight would create a spot on the Earth's surface with a temperature hot enough to boil water instantly, ignite virtually any combustible material, and cause devastating damage to structures and living things. Some estimates suggested temperatures at the focal point could exceed several thousand degrees Celsius, hot enough to melt steel. The tactical applications were horrifying in their scope. The weapon could theoretically destroy enemy cities, incinerate invading armies, boil rivers and seas, destroy crops, and create firestorms that would consume everything in their path. And perhaps most importantly from a strategic standpoint, there would be virtually no defense against it. You can't shoot down the sun after all. Now, let's address the obvious question. Could this actually have worked? The answer is complicated and depends heavily on what we mean by worked. From a pure physics standpoint, the basic concept is sound. Concentrating sunlight using mirrors can absolutely generate intense heat. We know this because we use this principle today in solar thermal power plants. Modern concentrated solar power facilities use thousands of mirrors called heliostats to focus sunlight onto a central receiver, creating temperatures hot enough to generate steam and drive turbines. However, scaling this up to a space-based weapon presents enormous challenges that the Nazi engineers would have had no realistic way to overcome with 1940s technology. First, there's the question of actually building and launching this thing. The proposed mirror would have weighed thousands of tons, even with the lightest possible materials. The V2 rocket, Germany's most advanced launch vehicle, could carry a payload of about 1 ton to a maximum altitude of roughly 120 miles, nowhere near the 5,100 miles proposed for the sun gun. You would have needed hundreds, possibly thousands of rocket launches to get all the components into orbit, along with the fuel, supplies, and personnel to assemble and operate it. Second, there's the engineering challenge of constructing such a massive structure in space. Keep in mind that in 1945, humanity had not yet launched a single artificial satellite. The concept of orbital construction, spacewalks, and space stations was purely theoretical. The first spacewalk wouldn't occur until 1965, 20 years after the war ended. Third, there's the precision problem. To focus sunlight onto a specific target from thousands of miles away would require extraordinarily precise control over the mirror's orientation. We're talking about adjustments measured in tiny fractions of a degree. Any atmospheric distortion, any wobble in the mirror's position, any imperfection in the mirror surface would scatter the beam and dramatically reduce its effectiveness. Fourth, atmospheric effects would severely limit the weapon's utility. When sunlight passes through Earth's atmosphere, it's scattered and absorbed by air molecules, water vapor, dust, and other particles. This is why the sun looks dimmer when it's near the horizon. Its light is passing through more atmosphere. A beam of concentrated sunlight coming down from space would lose a significant portion of its energy before reaching the ground, especially if there was any cloud cover. Modern analysis suggests that even under optimal conditions, the sun gun would have been far less effective than its designers hoped. The focused beam might create temperatures hot enough to be dangerous, but probably not the city-destroying inferno they envisioned. It would be more like a very large magnifying glass on a sunny day. Dangerous, yes, but not the ultimate weapon. By 1943 and 1944, Germany was losing the war on all fronts. The Luftwaffe had lost air superiority over Germany itself. Cities were being reduced to rubble by Allied bombing campaigns. The Eastern Front was collapsing, with Soviet forces pushing relentlessly westward. American and British forces had landed in Italy and would soon invade France. In this context, the appeal of a wonder weapon becomes clear. If conventional military forces couldn't win the war, then perhaps some revolutionary technology could. This wasn't entirely irrational thinking. After all, the atomic bomb would shortly prove that a single new weapon really could change the strategic balance of power. The problem was that Nazi Germany was pursuing too many wonder weapons simultaneously, spreading its limited resources too thin. Resources that could have been used to produce more conventional tanks, aircraft, and artillery were instead devoted to experimental projects with dubious military value. The Sun gun was perhaps the most extreme example of this tendency. Even if it had been technically feasible, which it wasn't, the resources required to build it would have been astronomical. The steel, aluminum, and electronics alone would have consumed a significant fraction of Germany's industrial capacity. The thousands of rocket launches needed to build it would have required the entire output of the V2 program for years. Moreover, the time frame was completely unrealistic. The most optimistic projections suggested the weapon might be operational within 50 to 100 years, long after the war would be decided by more conventional means. Some accounts suggest that when Allied intelligence officers examined the plans after the war, they found references to construction timelines stretching into the 1980s or beyond. The Sun gun never progressed beyond the planning stage. As the war ground to its inevitable conclusion in early 1945, work on exotic wonder weapons was abandoned in favor of desperate last-ditch conventional defense. The plans for the Sun gun were discovered by American forces as they advanced through Germany in the final months of the war. The documents were found at the German Army Artillery Proving Grounds in Hillersleben, along with plans for numerous other experimental weapons projects. American intelligence officers were initially astonished by what they found. Here were detailed technical drawings, calculations, and proposals for a weapon that seemed to leap straight from the pages of a pulp science fiction magazine. The discovery was reported in Life magazine in 1945, where it was presented as an example of the increasingly desperate and unrealistic thinking that had gripped Nazi leadership in the final years of the war. Hermann Oberth himself survived the war and eventually moved to the United States, where he joined his former student Wernher von Braun in the American rocket program. He worked on the development of American missiles and space vehicles until his retirement in 1962. Interestingly, despite his association with the Sun gun concept, Oberth was primarily known for his more practical contributions to rocket science and space exploration. He never publicly claimed credit for the Sun gun design, and some historians debate how much of the concept was actually his work versus the work of other engineers at the facility. After the war, the Sun gun became a footnote in the history of Nazi wonder weapons, a curiosity that exemplified the regime's combination of technological ambition and strategic delusion. It was occasionally referenced in discussions of space weapons and science fiction, but for the most part it was forgotten. However, the basic concept of space-based solar weapons didn't die with Nazi Germany. During the Cold War, both the United States and Soviet Union seriously studied various types of space-based weapon systems. The most famous of these was President Reagan's Strategic Defense Initiative, popularly known as Star Wars, announced in 1983. While SDI focused primarily on missile defense rather than offensive weapons, some of the proposed systems bore a conceptual resemblance to the Sun gun. These included space-based lasers, particle beam weapons, and kinetic energy weapons, all designed to destroy incoming missiles from orbit. There were also proposals for solar-powered laser systems that would use concentrated sunlight to pump high-energy lasers. While these were never built, the underlying physics was studied extensively. Modern military planners have occasionally revisited the concept of solar thermal weapons, though typically in much more modest forms than the massive mirror proposed by the Nazis. Interestingly, the peaceful application of space-based solar power has gained serious attention in recent years. Engineers have proposed launching satellites with massive solar panels that would collect energy in space and beam it down to Earth in the form of microwaves. These systems could theoretically provide clean, continuous power regardless of weather or time of day. Of course, the dual-use potential, a solar power satellite could potentially be weaponized, has not escaped notice among military planners and arms control advocates. The sun gun also influenced science fiction. Space-based solar weapons have appeared in numerous novels, films, and video games. The James Bond film Die Another Day features a satellite-based solar weapon remarkably similar to the Nazi concept. The similarity is probably not coincidental. The film's creators would almost certainly have been aware of the historical sun gun proposal. From a technological standpoint, we could theoretically build something like the sun gun today. We have the rocket capability to launch large structures into orbit. We understand orbital mechanics far better than 1940s engineers, and we have sophisticated computer systems that could handle the targeting calculations. But we don't for several good reasons. First, the Outer Space Treaty of 1967, signed by the United States, Soviet Union, and most other spacefaring nations, prohibits placing weapons of mass destruction in orbit. While a solar weapon might not technically qualify as a weapon of mass destruction under the treaty's specific wording, building one would certainly violate the spirit of the agreement and would likely trigger an international crisis. So what can we learn from the strange story of Germany's sun gun? I think there are several important lessons here. First, there's a cautionary tale about the dangers of prioritizing wonder weapons over practical military needs. Nazi Germany's obsession with revolutionary superweapons diverted crucial resources away from proven technologies and conventional forces. If the money and materials spent on the sun gun and similar projects had instead been used to produce more tanks, aircraft, and submarines, would it have changed the outcome of the war? Probably not. Germany was facing overwhelming odds by 1943, but it might have prolonged the conflict and caused more suffering. Second, the sun gun illustrates the importance of realistic assessment of technological timelines. Even if the weapon had been theoretically possible, the time required to develop and deploy it far exceeded the time Germany had left in the war. Grand visions must be tempered by practical considerations of what can actually be accomplished with available resources and time. Third, there's something to be said about the relationship between scientific ambition and ethical responsibility. The engineers working on the sun gun were, in many cases, brilliant scientists and engineers, but they were willing to place their talents in the service of a genocidal regime, developing weapons of mass destruction that could have caused unimaginable suffering. The story reminds us that scientific knowledge is morally neutral. It's what we choose to do with that knowledge that matters. Fourth, the sun gun shows us how desperation can lead to irrational decision-making. As Germany's military situation deteriorated, the leadership became increasingly willing to grasp at straws, pursuing fantastical schemes that had little chance of success. This pattern, turning to miracle solutions when facing defeat, is not unique to Nazi Germany. Throughout history, losing sides in conflicts have often placed their hopes in game-changing weapons or tactics that existed more in imagination than reality. Finally, there's a lesson about the power and danger of visionary thinking. Hermann Oberth's contributions to rocketry and space exploration were real and valuable. His theoretical work genuinely helped make spaceflight possible. But that same visionary capability could be harnessed for destructive purposes. The line between inspiring vision and dangerous fantasy isn't always clear, and the sun gun sits somewhere in that ambiguous space. The sun gun remains one of the most bizarre and ambitious weapon systems ever proposed. It represents the intersection of genuine scientific insight, desperate military circumstances, and the particular madness of the Nazi regime in its final years. From our perspective 80 years later, it's easy to dismiss the sun gun as pure fantasy, a fever dream of a dying dictatorship. And in many ways, that's exactly what it was. The technical challenges were insurmountable with 1940s technology. The resources required were beyond Germany's capacity, and the timeline for development stretched far beyond any reasonable military planning horizon. But we shouldn't entirely dismiss it as mere fantasy. The underlying physics was sound, even if the engineering was impractical. And in some ways, the sun gun was prophetic. It anticipated the space age, predicted the militarization of orbit, and foresaw technologies that would later be developed for peaceful purposes like solar thermal power. Today, we have the technology to build things that the Nazi engineers could barely imagine. We have space stations, satellite networks, and launch systems that can put massive payloads into orbit. We have precision optics, advanced materials, and supercomputers that could solve the targeting problems that would have stymied 1940s engineers. In theory, we could build something like the sun gun. But we don't, and hopefully we never will. Because beyond the technical questions of could we, lies the more important moral question of should we. The sun gun was designed to incinerate cities, to destroy populations, to be a weapon of terror and mass destruction. That some Nazi engineers thought this was a good idea tells us more about the moral bankruptcy of the regime they served than about the limits of human imagination. The story of the sun gun is ultimately a reminder that technology is only as noble or as terrible as the purposes to which we put it. The same scientific principles that could create a city-destroying death ray from space can also provide clean energy, enable peaceful exploration, and benefit humanity. The choice of which path to take is ours to make. So there you have it, the full story of Nazi Germany's plan to build a sun-powered superweapon in space. From ancient Greek legends to modern solar power, from desperate wonder weapon programs to the birth of the space age, it's a story that spans centuries and touches on some of the most profound questions about technology, war, and human nature. What do you think? Could something like the sun gun ever be built today? Should we be concerned about space-based weapon systems? Let me know in the comments below. And if you enjoyed this deep dive into one of history's most bizarre weapon proposals, make sure to like this video and subscribe for more fascinating stories from the stranger corners of history and technology. Thanks for watching, and I'll see you in the next video.